Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Routers and switches are two of the most critical devices in any wired network environment. Routers are responsible for connecting different networks and managing the traffic between them, while switches are used to connect individual devices within the same local area network. Together, they form the backbone of most home and business networks. Understanding how these devices operate, how they differ, and how they're configured is essential for any IT technician preparing for the CompTIA A+ exam or working in real-world network support roles. Routers perform several essential functions. At their core, routers direct traffic between different IP subnets, allowing devices on one network to communicate with those on another. Most commonly, a router connects a private local network to the broader internet, acting as the default gateway for devices within the LAN. In addition to basic traffic routing, routers may also provide services like Network Address Translation (NAT), Dynamic Host Configuration Protocol (DHCP), and basic firewall protection. These added features make consumer routers multifunction network hubs. The physical structure of a router typically includes multiple ports and interfaces. Most consumer-grade routers feature one wide area network (WAN) port to connect to the internet and several local area network (LAN) ports for wired devices. Some routers also include USB ports for shared printers or storage, and many offer integrated Wi-Fi radios for wireless connectivity. Port speeds can range from standard 100 megabits per second to 1 gigabit per second or higher, depending on the model. Understanding these ports helps technicians with proper setup and troubleshooting. Consumer routers are often equipped with a suite of features designed to support everyday use. These include NAT, which allows multiple devices on the LAN to share a single public IP address, and DHCP, which automatically assigns private IP addresses to connected devices. Many routers also act as wireless access points, broadcasting a Wi-Fi signal, and include DNS forwarding services to streamline domain name resolution. These built-in features are commonly found in small office and home network environments. Switches, on the other hand, operate within a local network to connect devices like computers, printers, and access points. Their primary role is to forward Ethernet frames based on MAC addresses, ensuring that data is sent only to the intended recipient rather than being broadcast to all devices. This improves efficiency and security within the LAN. Switches operate at Layer 2 of the OSI model and provide each device with a dedicated communication channel, unlike older technologies such as hubs, which simply broadcast all traffic. To understand the evolution of networking hardware, it's helpful to compare switches to hubs. Hubs are basic devices that replicate incoming data to every port, without regard to the destination. This leads to network congestion and potential data collisions. Switches, in contrast, maintain a MAC address table and send frames only to the destination port. Although hubs are now largely obsolete, they still appear in some exam questions, especially when discussing legacy hardware or troubleshooting noisy networks. Unmanaged switches represent the most basic form of network switch. These devices are typically plug-and-play and do not include any interface for configuration. Unmanaged switches are ideal for small environments where segmentation or advanced traffic control is unnecessary. They provide fast and reliable connectivity with minimal setup, but lack the ability to enforce policies, monitor traffic, or perform diagnostics. Their simplicity makes them suitable for home or small office use. Managed switches offer a much broader range of functionality. These devices include a command line or web-based interface that allows administrators to configure settings, monitor traffic, and implement security policies. Managed switches support advanced features like virtual LANs, VLANs, quality of service, QoS, simple network management protocol, SNMP, and port security. These capabilities are essential in business or enterprise environments where control, scalability, and performance are priorities. Some switches go beyond Layer 2 functionality. Layer 3 switches combine the switching capabilities of a traditional Layer 2 device with basic routing features. This means they can perform inter-VLAN routing and direct traffic between different subnets, effectively acting like a router in certain configurations. These devices are particularly useful in enterprise networks, where VLAN segmentation is implemented and require efficient routing without adding a standalone router to the design. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Configuring a managed switch involves several administrative tasks that allow technicians to control and optimize network behavior. One of the first steps is assigning an IP address to the switch, which enables remote access via a web browser or command line interface. Additional tasks may include creating and assigning VLANs to segment traffic, configuring trunk ports to carry multiple VLANs between switches, setting up port mirroring for diagnostics, and applying security features like MAC address filtering. Each of these steps helps tailor the switch's operation to the needs of the environment. Managed switches offer clear advantages in terms of network control and flexibility. They support segmentation, which improves performance and security by isolating traffic between user groups. They also allow for bandwidth allocation, traffic prioritization through QoS, and detailed monitoring through SNMP. Managed switches can be updated with firmware to address security vulnerabilities or enable new features. These capabilities make them the preferred choice for organizations that require a scalable and secure networking solution. Despite their advantages, managed switches come with drawbacks. They are more expensive than unmanaged models, which may be a barrier for smaller organizations. They also require technical expertise to configure and maintain, and improper setup can lead to network instability or outages. For example, misconfigured VLANs can break inter-device communication, and incorrect port settings may cause devices to lose connectivity. As a result, these switches are best suited for environments with trained IT staff. Unmanaged switches are most appropriate in small, static environments where advanced features are unnecessary. These devices are ideal for simple home networks, small offices with a flat network structure, or temporary setups in labs or testing spaces. They provide essential switching functionality with zero configuration, making them quick to deploy and maintain. However, they are not suitable for networks that require monitoring, traffic shaping, or device isolation. Routers serve different purposes depending on the size and complexity of the network. In home and small office environments, consumer routers typically provide routing, wireless access, and security features like NAT and firewalls. In larger networks, enterprise-grade routers manage connections between remote sites, route traffic between subnets, and support advanced features like VPN connectivity and redundant WAN links. These routers often have higher throughput, support for modular expansion, and enhanced software capabilities. Switches and routers work together in most network environments. The switch handles communication between devices on the same local network, while the router connects that network to other networks, such as the Internet. A typical layout involves end-user devices connecting to a switch, which then connects to a router that manages WAN communication. Proper addressing, subnetting, and cabling must be in place to ensure seamless interaction between these components. Many switches now offer Power over Ethernet or PoE, which allows a single Ethernet cable to deliver both data and electrical power to connected devices. This is commonly used for IP phones, wireless access points, and security cameras. PoE simplifies installation by eliminating the need for separate power sources at each endpoint. While PoE is most often found on managed switches, some unmanaged models also offer basic PoE functionality for simple deployments. The A+ exam includes a range of topics related to routers and switches. Candidates may be asked to identify devices by port type or role in a network diagram, select appropriate devices for specific scenarios, or troubleshoot connectivity issues. Common issues may involve incorrect IP addressing, improper VLAN configuration, or port-level failures. Understanding both the capabilities and limitations of managed and unmanaged devices is crucial for answering exam questions correctly. Switch port LEDs provide quick visual insight into the status of each connection. A solid link light indicates that a connection is present, while a flashing light typically means data is actively being transmitted or received. Some switches include color-coded indicators that show connection speed, such as green for gigabit and amber for 100 megabit. The A+ exam may include questions about interpreting these indicators, especially when troubleshooting connectivity or identifying cable faults. To summarize, routers and switches are foundational devices in any networked environment. Routers connect different networks and manage traffic between them, while switches connect individual devices within a local network. Managed switches offer extensive configuration and monitoring options, while unmanaged switches provide basic connectivity with minimal setup. Knowing how to deploy, configure, and troubleshoot these devices is a core part of A+ certification and essential knowledge for IT support professionals working in networked environments. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.